Good morning from Kennedy Space Center and Cape Canaveral Space Force Station in Florida. Welcome to Spaceflight Now's live coverage for the second launch attempt for Relativity Space's Terran 1 rocket at the Cape. You're looking live at Launch Complex 16, where Relativity Space is currently loading propellants into the Terran 1 rocket. This is a methane-fueled launch vehicle. This vehicle, if it successfully reaches orbit on this test flight today, will become the first methane-fueled rocket to reach Earth orbit. This is the very first launch attempt, or very first launch for Relativity Space, which has developed this Terran 1 rocket, which is a two-stage vehicle capable of carrying about 1,250 kilograms, a little over a ton of payload into low Earth orbit. The vehicle stands 110 feet tall. That's 33.5 meters in height. This is one of multiple new privately funded small and mid-class launch vehicles coming to market. This vehicle is larger and more powerful than many of those new entrants, such as Rocket Lab's Electron or Virgin Orbit's Launcher 1. This is on the upper end of that spectrum of small to mid-class vehicles, again, with a payload carrying capacity of more than a metric ton to low Earth orbit. Now, 1 hour, 28 minutes until the opening of Relativity's 3-hour launch window. That window opens at 1 p.m. Eastern Standard Time, or 1800 UTC, and runs for 3 hours. Relativity scrubbed their first launch attempt back on Wednesday due to concerns about liquid oxygen on the second stage of the Terran 1 rocket being warmer than predicted. They obviously want to make sure that the cryogenic oxidizer, which is chilled down to a couple hundred degrees below zero, is at the proper temperature. They don't want warm liquid oxygen, warmer than expected liquid oxygen in the system, because there's a chance that liquid oxygen could boil off and form gas bubbles, and that's obviously a concern for the performance of the engines if there are gas bubbles in the propulsion system. So they stood down from that launch attempt on Wednesday. It took some time to recondition propellant, and now they're making another run at launch today at Cape Canaveral Space Force Station. My name is Stephen Clark. I'm the editor of Spaceflight Now. I'll be providing a live commentary throughout the countdown today, as well as the Terran 1 rocket's 8-minute climb into orbit. Propellant loading on board the vehicle was to begin around 4 hours before the target launch time, which currently is still set for 1 p.m. Eastern Time, the opening of the 3-hour window today. If you haven't done so yet, we ask and request that you please hit the thumbs up or the like button here on our YouTube stream. That helps us gain a larger audience as the countdown heads down toward launch time. Weather conditions here in Florida look favorable for launch with clear skies. The winds at the surface are light to moderate out of the north, and there's a 90% probability of favorable weather conditions today for launch during this 3-hour window. The countdown clock is now holding at 1 hour, 24 minutes, 17 seconds, as you can see in the upper right. So this is a good indication that the launch time has been reset, and the clock is now winded back to 2 hours and 8 minutes. So we'll see when the clock picks up, and once the clock picks up, we'll have an idea of the new target launch time for Relativity Space this afternoon. But this is an indication that the launch will not be happening at the opening of the window at 1 p.m. Eastern Time. We'll stand by for confirmation of that. The clock has now resumed at 2 hours, 8 minutes, and counting. So it looks like the new target launch time is 1:45 p.m. Eastern Time, or 18:45 UTC. Now 1 hour, 54 minutes, 35 seconds remaining until the updated target launch time this afternoon at 1:45 p.m. Eastern Time. That is 18:45 UTC for those of you in other time zones. We're seeing some periodic venting from the Launch Complex 16 strongback from the Terran 1 rocket launch vehicle. This is likely gaseous oxygen venting as part of the propellant loading process. So this venting does indicate that Relativity is loading propellants into the vehicle in anticipation of a launch opportunity this afternoon. The teams have said they're monitoring upper-level winds, which are a concern this afternoon. The weather conditions here locally at the Cape are favorable for launch at the surface, with clear skies, as you can see here in this view from Kennedy Space Center, just a few miles to the north of Launch Complex 16. It is a little bit breezy this afternoon, but winds are well within limits at the surface. The concern is with winds at different levels in the upper atmosphere and the potential of wind shear that could cause a problem for the Terran 1 rocket as it makes its way into space. So weather conditions here in Florida at the Space Coast look good. The main weather concern right now is upper-level winds. The 45th Weather Squadron here at Cape Canaveral sends a series of weather balloons into the atmosphere during every launch countdown to monitor winds at different levels of the atmosphere. And then that data is then handed over to each launch provider, in this case Relativity Space, which uses their own calculations and algorithms to determine if the winds are acceptable for flight, if the Terran 1 can safely traverse those wind shears in the upper atmosphere. Here's a look once more at Launch Complex 16. We're also seeing some periodic activity at the methane flare stack. That's the flame that burns off methane that comes off the launch vehicle during the loading process. Make sure that there's no residual methane in the ground system or the lines or in the atmosphere during the engine startup sequence during the launch sequence. It reduces the risk of an explosion or any fire. And that's the reason for that flare stack. We often see those flare stacks, of course, at petroleum refineries. But launch pads have those as well, particularly launch pads that deal with fuels like methane or hydrogen. 1 hour, 52 minutes now until the new target launch time, if you're just joining us, which is 1:45 p.m. Eastern Standard Time. Now less than 1 hour and 40 minutes away from the new target launch time, which is now 1:45 p.m. Eastern Standard Time, or 18:45 UTC. For those of you who are just joining us and haven't heard our previous updates, there has been a 45-minute delay in the launch time for Relativity Space's Terran 1 rocket. We're not sure yet of the reason for that delay. However, Relativity does have a 3-hour launch window to work with this afternoon here at Cape Canaveral, Florida. The window runs from 1 to 4 p.m. Eastern Time, so it closes at 2100 UTC. Relativity's first launch attempt back on Wednesday was scrubbed. It was actually halted. The countdown stopped at T-minus 70 seconds, right at the start time of the terminal countdown sequence, when sensors detected liquid oxygen on the upper stage of the rocket was too warm, not at the right temperature. So Relativity halted the countdown and studied the problem and decided to call off the launch attempt and allow more time to troubleshoot that issue and condition the propellants in advance of today's launch attempt, which is the second launch attempt for this Terran 1 test flight. The Terran 1 rocket that you're looking at live at Launch Complex 16 is the very first 3D printed methane-fueled orbital class rocket to reach this point in a launch campaign. It's ready for its first flight today if everything comes together for Relativity Space. Methane, or liquid natural gas, is a popular new propellant type, fuel type for new rockets. SpaceX's Starship and Super Heavy launch vehicle, which is nearing its first test flight, orbital test launch from South Texas, also uses methane as a fuel. It's a much larger vehicle than the Relativity Space Terran 1, which is 100 feet tall. The Starship and Super Heavy, 4 times the height at 400 feet tall. United Launch Alliance has their Vulcan rocket nearing its first launch attempt as well in the May timeframe. The Vulcan rocket is powered by 2 BE-4 main engines at the base of the first stage. Those BE-4s made by Blue Origin also use the same propellant mixture, methane and liquid oxygen, as the Terran 1 and the Starship. In fact, just a few miles to the north of Launch Complex 16, United Launch Alliance has their Vulcan rocket, their first flight-qualified Vulcan launch vehicle, on Pad 41, undergoing some testing. They loaded methane and liquid oxygen into the first stage of that Vulcan rocket yesterday during a fueling demonstration. They plan in the coming days and weeks to load propellant also into the Centaur upper stage, which has liquid hydrogen and liquid oxygen as its propellant mix. And then perhaps by the end of the month, if everything goes according to plan, ULA plans to test fire the BE-4 engines for a 6-second burn on the launch pad. That'll be a final hold-down test firing for the launch campaign to make sure everything is ready to go, both on the ground system side and the flight side on the launch vehicle. And then ULA will prepare the Vulcan rocket for liftoff no earlier than May the 4th. They'll return the rocket to its hangar, integrate it with its payload, which will consist of an astrobotic lunar lander, as well as 2 test satellites for Amazon's Kuiper broadband network. They'll also attach 2 strap-on solid rocket boosters to the Vulcan main stage, then roll the vehicle back out to the pad for its launch attempt. So the Terran 1 at Launch Complex 16, if it reaches orbit, will take the record as the very first methane-fueled rocket to reach low Earth orbit, beating out its larger competitors, not direct competitors, but larger counterparts in the launch industry, the Starship and the Vulcan. Again, if you're just joining us as we monitor the Relativity Space Terran 1 rocket, if you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us attract a larger audience with the help of the YouTube algorithm, as the countdown is now 1 hour and 33 minutes from launch time. Liftoff time, again, is targeted now for 1:45 p.m. Eastern Standard Time, or 1845 UTC. Propellant loading on the Terran 1 rocket is underway out at Launch Complex 16. Also, if you want to support our coverage, you can donate and contribute in our Super Chat here on our YouTube channel. If you contribute in the Super Chat, we really would appreciate that. If you're able to do so, it helps us bring you launch coverage like this coverage we're bringing you today. It's a very busy time here at Cape Canaveral Space Force Station, and sometimes it is a challenge to keep up with the busy cadence of launches, and your donations help us bring you live video as well as our comprehensive coverage on our website at www.spaceflightnow.com. You can also support our coverage by joining our YouTube channel, becoming a member. Depending on which membership level you select, you can gain access to bonus members-only video features that we have posted and produced just for our members and our loyal supporters. And of course, you'll be also helping us bring you our independent launch coverage here at Cape Canaveral, Florida. Relativity's countdown now passing T-minus 1 hour 30 minutes, 90 minutes away from the new target launch time of 1:45 p.m. Eastern Standard Time, 1845 UTC. Again, weather conditions here at Cape Canaveral, Florida, look favorable for liftoff of the Terran 1 rocket. It is breezy, but the winds at the surface, at least, are within limits for liftoff. There's a 90% probability of weather locally here at Cape Canaveral, Florida, to be acceptable for launch. However, there is another weather concern that's not factored into that probability, which is upper-level winds. Relativity says those are a concern today. They're monitoring upper-level wind conditions to make sure that they're going to be acceptable for flight. The concern is with wind shear and changes in wind velocity and direction at different layers of the atmosphere as the Terran 1 climbs into space. The 45th Weather Squadron here at Cape Canaveral launches a series of weather balloons throughout every countdown. Those weather balloons gather data on conditions, including winds, in the upper atmosphere and then that data is handed over to each launch provider, which does their own assessment using their own calculations and algorithms to match those wind conditions with the performance of their rocket and the design of their rocket, and then determines whether the winds are safe for flight. Each launch vehicle has different upper level wind constraints depending on the shape and power and size of the launch vehicle. So whether upper level wind conditions which may be acceptable for ULA or a SpaceX launch may not be acceptable for Relativity Space, or vice versa, depending on the exact conditions at which altitude and which direction. One hour, 25 minutes until Relativity Space's updated launch time of 1:45 p.m. Eastern Time. The flame that you see off to the right of the Terran 1 rocket at Launch Complex 16 is the methane flare stack, which burns off methane coming off of the rocket and the ground systems to reduce the risk of any fire or explosion during the countdown. Obviously, methane is a flammable gas and or liquid in the form that it's loaded into the vehicle. So that flare stack serves a similar purpose as you may see flare stacks at petroleum refineries, burning off excess fluid. I want to answer a question from one of our viewers who just asked, what are the advantages of a methane-powered engine over the RS-25 rocket used by NASA, as well as SpaceX? The RS-25, of course, is the engine used on NASA's Space Launch System for the Artemis moon program. Also was used on the Space Shuttle. It burns liquid hydrogen as its fuel. So liquid hydrogen is more efficient, has more of an impulse per unit of fuel than methane. However, the hydrogen does come with a couple of disadvantages. It's more difficult to store and to load into rockets, It's obviously a very small molecule, smaller than CH4, which is methane. So it's more prone to leaks, as we saw during the Artemis launch campaign on the Space Launch System. As that rocket was prepared for launch, there were a number of leaks discovered throughout testing last year before the successful launch in November. Methane also has the advantage of it is potentially manufacturable and producible on other planets using resources on Mars. So companies that have a vision to go to Mars, such as SpaceX or Relativity Space, also shares that ambition. Want to use methane because they could actually eventually set up depots and production facilities on the surface of Mars to produce methane for return trips to Earth. And that's obviously in the distant future, decades away. But they want to transition to this fuel, to methane, to start testing it and to practice, basically, for future production, potentially, of methane on other worlds. Methane also has an advantage over kerosene, which is used on SpaceX's Falcon 9 rocket. Kerosene also is used on ULA's Atlas V rocket, as well as Russia's Soyuz. The methane leaves less deposits or residue in the engine system after each burn than kerosene does. So it actually is easier to refurbish engines. It requires less cleaning of engine hardware and plumbing between flights. So it eases the reuse of engines and rocket stages when you use methane. And if you're just joining us and you haven't done so, please hit the thumbs up or the like button here on our YouTube stream. That helps us attract a larger audience for our coverage. T-minus 1 hour, 15 minutes and counting for the first test flight of Relativity Space's Terran 1 rocket. If you're just joining us, my name is Stephen Clark. I'm the editor of Spaceflight Now. We're reporting live from Kennedy Space Center and from Cape Canaveral Space Force Station. My colleague Stephen Young is operating the camera that you're seeing now, looking at Launch Complex 16, where the 110-foot tall or 33.5 meter Terran 1 rocket is currently being loaded with propellants. The propellant loading process should be nearing completion right now. We will bring you closer views of the rocket once Relativity brings those views to us. We expect that to begin in about 15 minutes or so, and we'll filter those views into our coverage when we get them. Again, this is the Terran 1 rocket, a privately funded launch vehicle developed by Relativity Space, a company headquartered out in Long Beach, California. This is a busy day in the world of space flight. Aside from the Relativity Space launch attempt that we're covering right now, 4 astronauts, or actually 3 astronauts and 1 Russian cosmonaut, are on their way back to Earth as we speak from the International Space Station aboard SpaceX's Dragon Endurance crew capsule. The 4-person crew, led by NASA Commander Nicole Mann and pilot Josh Cassada, Japanese astronaut Koichi Wakata, and Russian cosmonaut Anna Kikina, undocked from the International Space Station very early this morning at 2:20 a.m. Eastern Time, 7:20 UTC, for a 19-hour transit, culminating in a re-entry and splashdown in the Gulf of Mexico tonight off the coast of Tampa, Florida. That splashdown is scheduled for 9:02 p.m. Eastern Time, 2:02 a.m. UTC tonight. This will wrap up a 5-month expedition for these crew members aboard the International Space Station on the NASA SpaceX Crew 5 mission. They have been replaced aboard the International Space Station by the Crew 6 mission, which launched last week from here at Kennedy Space Center on a SpaceX Falcon 9 rocket and Dragon spacecraft. Also this evening at Wallops Island, Virginia, on the eastern shore of Virginia, Rocket Lab is set to launch an Electron rocket with 2 satellites, or radar observation satellites, for the commercial company Capella Space. Those satellites will be heading into a mid-inclination orbit aboard Rocket Lab's Electron launch vehicle. This is Rocket Lab's second flight from their new launch site in Virginia, their 34th launch overall, including missions that have flown out of their primary base down in New Zealand. That Rocket Lab launch window opens at 6 p.m. Eastern Standard Time, 2300 UTC tonight, weather permitting. The Electron should take off during that window from Virginia. We'll cover that on our website at www.spaceflightnow.com. If you go to our website as well, you can go to the launch schedule and you will see a listing of all the near-term upcoming launches with confirmed dates around the world. And you'll never miss a launch if you refer to that. At least you'll never miss a launch that has a live broadcast if you refer to that. There are launches from China and Russia, for example, that don't have live coverage. 1 hour, 11 minutes to go now until the new target launch time for Relativity Space, still set for 1:45 p.m. Eastern Time at last report. T-minus 1 hour, 3 minutes, 40 seconds until the new target launch time for Relativity Space, which, if you're just joining us, is now set for 1:45 p.m. Eastern Time, 18:45 UTC. The launch time had been originally targeted this morning for the opening of the 3-hour window at 1 p.m. So that's a 45-minute delay. Relativity hasn't said the reason for that slip. However, not unexpected with the first launch of a new rocket. The window today runs until 4 p.m. Eastern Standard Time, 2100 UTC. Now, 55 minutes until Relativity's target launch time of 1:45 p.m. Eastern Time. As you can see here, the weather conditions at Cape Canaveral are favorable for launch with clear skies. It is a bit breezy outside right now, but those winds are not expected to be a concern, at least at the ground level. However, Relativity has said they are monitoring upper level winds, which may be a concern this afternoon. That has to do with wind shears at different altitudes in the upper atmosphere. Here's a view of Relativity's Terran 1 rocket on Launch Complex 16. So we're now getting some live video from Relativity Space as the countdown passes under 54 minutes until launch time. You can see the venting from both stages of the Terran 1 rocket, indicating propellant loading is underway and actually should be wrapping up in the next few minutes. Relativity Space, their countdown timeline actually calls for loading propellants early on in the launch countdown, and then getting into what's known as a stable replenish mode for the final terminal countdown sequence. Again, we're standing by for the launch of Relativity Space's Terran 1 rocket. We had a brief glitch with our camera looking across the water at Launch Complex 16. So we're working on resolving that. We'll bring that to you. We'll bring that view to you of Pad 16 once we have it. Again, we're standing by for restoring our camera view of Launch Complex 16. So we're standing by to restore our camera view of Launch Complex 16. And now we have that view back of Launch Complex 16 live, 50 minutes until liftoff time. T-minus 49 minutes, 8 seconds and counting. We just heard an update from Relativity Space that the upper level winds that we've talked about, the winds in the upper atmosphere, right now are go for launch. They're acceptable for flight, but they'll continue monitoring these upper level wind conditions with the help of data from weather balloons throughout the rest of the countdown. The concern is to make sure that the Terran 1 structure margins, as well as the steering authority of the thrust vector control on the Aeon engines at the bottom of the first stage, is sufficient to steer the rocket through these wind shears, different wind velocities from different directions at different levels of the atmosphere. Again, this is the second launch attempt for Relativity Space's first Terran 1 rocket. The launch attempt back on Wednesday was aborted. There was a malfunctioning ground propellant valve, according to Relativity, that prevented liquid oxygen from maintaining the proper temperature on the second stage of the Terran 1. So they've done some troubleshooting and some propellant conditioning since then to ready for today's countdown. The launch show was delayed for 3 days instead of recycling to attempt 24 hours later to allow time for conditioning of methane. They want to make sure that the methane is at the right concentration for loading into the Terran 1 rocket. That takes a few days, according to Relativity, between launch attempts. This view looks off to the northeast across the Banana River, about 7 miles away from Launch Complex 16 at Cape Canaveral Space Force Station. Relativity Space and the Space Launch Delta 45 of the U.S. Space Force here at the Cape are not providing on-site media support for today's mission, despite our request for them to do so. This is rather unusual for a launch such as this, a first launch of a new rocket. But we did ask for a closer view as the Space Force and customers, launch operators typically provide to us news media. But they declined to do so, and the Space Force said that was at the request of Relativity Space for this first launch of their Terran 1 rocket. But we do have a view of the pad, as you can see, 7 miles away, an independent view we can bring you. We'll track the Terran 1 as it climbs off the pad this afternoon. We'll also mix this in with feeds from Relativity Space's own cameras closer to the launch pad throughout our coverage. Continuing to see some flare stack activity from the methane burn-off system at Launch Complex 16. Now 42 minutes until liftoff. T-minus 40 minutes, 30 seconds. Let's take a look at the design of Relativity Space's Terran 1 rocket. This rocket is designed and built by Relativity Space, which was established in late 2015 by Tim Ellis and Jordan Noon, who were former engineers at Blue Origin and SpaceX. They set up Relativity Space, which is headquartered now in Long Beach, California. Relativity now boasts a factory there, a former Boeing airplane factory where they build the Relativity Terran 1 launch vehicle, 1 billion square foot of factory space in Long Beach, California, as well as more than 1,000 employees currently at Relativity. This Terran 1 rocket is 110 feet or 33.5 meters tall. It's 7.5 or 2.3 meters in diameter. It's fueled by methane with liquid oxygen as the oxidizer. The structural mass, about 20,000 pounds or 9 metric tons. The dry mass of the vehicle is 85% 3D printed using a proprietary aluminum alloy that Relativity has developed. The Terran 1 rocket can loft about 1,250 kilograms or 2,755 pounds of payload to low Earth orbit. At liftoff, the 9 Aeon engines at the bottom of the first stage will generate more than 200,000 pounds of thrust. Here's a look at the configuration of the 9 Aeon engines at the base of the first stage of the rocket. This was captured during a hold-down test firing last September. Relativity Space performed a series of tests at Launch Complex 16, ramping up to ultimately an 88-second firing of all 9 Aeon engines, which was nominal and as expected according to Relativity Space. Relativity elected not to do a full duration 2-minute 40-second firing of the 9 engines on the first stage last month. They decided to proceed into a launch campaign and a launch attempt, which they are now moving forward with. We saw the first launch attempt on Wednesday, which was scrubbed due to propellant conditioning issue, and another launch attempt is on tap today. We had a chance to talk to Josh Brost, the Vice President of Revenue Operations at Relativity Space, earlier this week. He talked to us about the expectations going into today's launch attempt, as well as talking a little bit about what would determine mission success for this test flight as Relativity Space attempts to place the first 3D printed rocket and the first methane-fueled rocket into low Earth orbit. Let's listen to Josh, as I had a chance to talk to with him a few days ago.
And Josh, going into this first flight of the Terran 1, this is a first launch. I know there's always some risk going into a first test flight. Can you set the
Sure.
table for us in terms of the significance of this moment for your company, for Relativity, and also what would define success on this first test flight?
Sure. Yeah, there's a lot to that question, so I'll try to break it down. So first I'll start with just, pointing out no uh, new company has ever had their liquid rocket make it to space on their first attempt. So if everything goes incredibly well and we achieve orbit on our first launch on Wednesday, that would be a remarkable milestone for us, which we'd be, of course, over the moon excited about. But that isn't what defines success for us. I mean, that would obviously be the home run, but there are many other things that could happen on launch day that would still be considered very successful for us. I think ultimately, this first launch is really the kind of crowning milestone of many years of work by our entire team to get us to this point. We've developed a brand new manufacturing technology that we've validated through testing on the ground. We've developed brand new rocket engines, which are very difficult and complex technical systems that operate right on the edge of what physics says is possible. We've developed brand new millions of lines of code to operate this whole system, a brand new launch site. And while you can test each of these systems separately on the ground, you really can't do an end-to-end test until you fly. There are just certain things that are different in flight than they are on the ground. And so the flight test is the ultimate validation of that system and of all the learnings that we've had over the last several years. Because there are a number of firsts here potentially on this rocket. It has the chance of being the first liquid natural gas, liquid oxygen rocket to make it to orbit. It is has by far the highest 3D printed content of any rocket in history. We're sitting at about 85% by mass, where I don't think any other rocket has gone past maybe 4%. It's probably less than that. So there's lots of exciting potential firsts here. I think for us as a company, we feel like we've done the testing on the ground to validate that 3D printed structures can survive the launch environment, but obviously demonstrating that in flight will be an important milestone to get through. And as we look at the day of flight operations, you see maximum Q happens partway into stage 1 ascent. That's the point where you get the maximum aerodynamic forces pushing on the rocket. That really is a key validation point for us to show, not just to ourselves, but to the world, that a 3D printed rocket is really up to the task of taking on those launch environments. And then beyond getting to max Q, it really is about maximizing learning. So it's collecting as much data as possible that we can then use to improve our analytical capabilities on the ground and improve our testing capabilities on the ground as we want to carry on forward to what's next.
One thing about excuse me, one thing about Relativity that always strikes me is you're not only developing a new launch vehicle, which itself is very difficult, but you're also developing an entirely new manufacturing method and system with your 3D printing technology, which I believe is largely from scratch. So talk about the challenges of those dual paths.
Yeah, I mean, rockets are incredibly difficult systems to develop. One of my former colleagues liked to use the saying that when the clock gets to 0, a million things can happen and only one of them's good. And that's because rockets are incredibly complex systems that are tightly coupled, where your avionics, your propulsion system, your structures, all these things need to work perfectly in concert to have a rocket ultimately achieve orbit. And so it's adding on to developing the rocket, developing a manufacturing platform is another really challenging thing. Instead of using systems that have been vetted by decades of experience, in some ways, we needed to reinvent tool sets, to make it not only possible to print a large scale rocket, but to print it reliably. So, being able to avoid creating flaws, to detect flaws where they were, to repair flaws where necessary. All of these tools were things that we had to develop ourselves, which added to the complexity of getting to our first launch. But it also makes that first demonstration all the more important and meaningful for us as a company. I think the great thing about 3D printing is it is a technology that we see, holds the keys to accelerating the pace of innovation in the industry, and that's why we've been such heavy proponents of it. And demonstrating its capability through launch will be an exciting next step for all of us.
What theoretically, and maybe also empirically from your ground testing, what does that information tell you about the strength of these 3D printed structures and tanks compared to carbon fiber or aluminum or stainless steel or something like that?
Yeah, I mean, it's a bit of apples and oranges when you compare different materials, but ultimately we're designing the rocket to have the same kind of safety factors and structural margin that you would see in any other system. And so really you design your rocket to be just strong enough to do the mission that it needs, because every bit of additional strength is additional mass that you're carrying to space, instead of taking payload to space. And so from that standpoint, you end up kind of the same as other rockets. And over time we have developed our own alloys to make the printed material both higher performance and more printable, which is part of our very unique tech stack that makes it possible to 3D print an entire, the vast majority of a rocket.
85% by mass created through 3D printing technology.
Yes.
What the other 15%? What types of components aren't quite ready for 3D printing yet?
It's a variety of things. Most of what's not 3D printed are things that are readily purchased off the shelf. There are certainly parts in, what we're really focusing is on printing metal structures, or basically metal structures or propulsion components. And so you'll see things like fasteners aren't 3D printed, some of the valves aren't 3D printed. A lot of the avionics system, both the avionics boxes, the computers inside, and the harnessing that attaches them aren't 3D printed. And really that's where we were trying to push the envelope to demonstrate how, to really expand what's possible with 3D printing. But at the end of the day, we were also trying to be pragmatic about which parts actually benefit from being 3D printed. And really optimizing for having the best launch system, not for hitting 100% or something.
Is everything, the 3D printing, does it go down into like the turbo machinery of the engines and thrust chamber, things like that, or is that all coming off your 3D printer as well?
So we incorporate a number of different 3D printed technologies, some of which we developed in house, some of which are come from other companies. But yeah, it's a wide variety of things, from the primary structure to you'll probably have seen pictures online of our engine on a test stand, and the thrust chamber, and many of the housings. Some other key components are 3D printed. Injectors are a place where 3D printing has been widely adopted and drives tremendous benefits.
That was Josh Bross, the Vice President of Revenue Operations at Relativity Space, telling us a little bit about what we can expect in today's Terran 1 test flight, now 28 minutes away from liftoff at Cape Canaveral Space Force Station here in Florida. Bross also talked about some of the key moments in the mission, such as max Q, the period of maximum aerodynamic pressure, when the launch vehicle will experience the peak forces, structural forces, aerodynamic forces on the vehicle. Again, the weather conditions here at Cape Canaveral Space Force Station look favorable for launch. With clear skies, there is a concern with upper-level winds, but at last report, the upper-level wind conditions were favorable for launch, were acceptable for liftoff today. 27 minutes now until liftoff. Now it's at 27 minutes until launch. Here's a view inside of Relativity's Launch Control Center here at Cape Canaveral, Florida, where teams are gathered. You can see the members of the launch team looking at their data displays. They're led by Launch Director Clay Walker, who is going to be providing updates to us on the progress of the countdown. There will be a pre-launch readiness poll at T-minus 16 minutes, about 10 minutes away, at which point we hope to get confirmation that the countdown is going to proceed this afternoon. Less than 25 minutes until launch time. We're awaiting a briefing from Launch Director Clay Walker, who is in the back center of this view with the beard and the pink shirt inside Relativity's Launch Control Center at Cape Canaveral Space Force Station. This is located in the KSC industrial area, a few miles from Launch Complex 16. That briefing should be coming up in a few seconds. We'll pass along any news to you that we hear from it. If you're just joining us and you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us gain a larger audience for our coverage. We want to bring this launch to as many people as possible. With the help of the YouTube algorithm and your thumbs up or like, we'll be able to do that. Also, if you want to support our coverage, please consider donating through the Super Chat here on YouTube. That contribution would help us maintain and extend our coverage of launches here at Cape Canaveral. This is the second launch of the week. Just a couple of days ago, SpaceX launched a Falcon 9 from the Cape with a batch of 40 OneWeb satellites. Today, Relativity Space is making a run at their first test flight a few miles away to the south of the SpaceX pad for the Terran 1 rocket. And to help us keep up with this busy cadence of launches, please consider donating in the Super Chat. We would really appreciate your support there if you're able to do so. Here's a look at the countdown timeline. Vehicle power-up and checkouts began about 7 hours before liftoff this morning. Personnel cleared Launch Complex 16 in anticipation of today's launch attempt at 4 hours before launch. That's the same time that propellant loading got underway, methane and liquid oxygen. Propellant loading was completed at T-minus 1 hour. And then coming up, one of the next big milestones will be the pre-launch readiness poll by Launch Director Clay Walker at Relativity's Launch Control Center. That'll be at T-minus 16 minutes. At T-minus 10 minutes, the automated countdown sequence will begin. The terminal countdown sequence will begin at T-minus 70 seconds. And then at T-minus 6 seconds, the 9 Aeon engines on the first stage of the Terran 1 will ignite. If those engines are performing well, the computer will give the command for liftoff at T0. Now 20 minutes, 30 seconds away from liftoff. Here's a look at the Terran 1 rocket compared with a new vehicle that Relativity Space is developing called the Terran R. The Terran 1 is what we hope to see launch this afternoon. It's 110 feet tall in this configuration, 33.5 meters, and is an expendable rocket. And we just heard from Relativity Launch Control that the countdown clock will be holding at T-minus 20 minutes, and there you see it stopped at 20 minutes to evaluate upper-level wind conditions. There's a violation of upper-level wind conditions right now. These are the wind shears at various levels in the upper atmosphere that Relativity Space checks to make sure that the rocket has steering authority with its thrust vector control system to safely fly a path through those changing wind speeds and directions at different altitudes. There's no new target launch time yet. However, Relativity does have a launch window that extends until 4 p.m. Eastern Standard Time or 2100 UTC. as Relativity's countdown continues in this hold at T-minus 20 minutes. The team is waiting for an improvement in upper level wind conditions to make sure that the winds at various levels of the atmosphere will be acceptable for flight today. So the countdown is now holding at T-minus 20 minutes and holding. Again, this is a unplanned stoppage of the countdown to wait for upper level wind data to confirm that wind shear conditions in the upper atmosphere will be acceptable for flight this afternoon at Cape Canaveral. Here's a look at the countdown timeline. Right now, the countdown is holding at 20 minutes, so the next milestone in the countdown will be the pre-launch readiness poll by Launch Director Clay Walker here at the Cape. That'll be at 16 minutes once the clock resumes. And then at T-minus 10 minutes, the computer-controlled automated countdown sequence will begin. Things like the chill down of the Aeon engines on the first stage, thermal conditioning of those engines will begin during that final 10-minute automated sequence, as well as priming of the igniters on both stages, and configuration of the autonomous flight safety system as well on the rocket. That's the destruct system that would be used to destroy the rocket in the event of a major malfunction after liftoff. The terminal countdown will begin at 70 seconds. That will begin the final checks of all launch commit criteria. Make sure all systems on the vehicle and the ground systems are ready. And then the engine start command will be given at T-minus 6 seconds with the ignition of the 9 Aeon 1 engines. These methane-fueled engines will ramp up to full throttle, 207,000 pounds of thrust equivalent at sea level. If everything looks good, the command will be issued by the flight computer to release hold-down restraints at T0. These hydraulic restraints will release, allowing the Terran 1 rocket to begin its climb into space from Launch Complex 16. This will be the 13th launch of the year from here on Florida's Space Coast, from pads both at Kennedy Space Center and at neighboring Cape Canaveral Space Force Station. The 45th, or the Space Launch Delta 45 officials here who run the Eastern Range are expecting as many as 92 launches this year from various pads, and this will be number 13 of the year today with the Relativity's Terran 1 rocket. The lion's share of these missions in blue on this graph are from SpaceX. All of the launches so far this year from the Cape have been SpaceX missions. Today is the first for Relativity Space and the Terran 1 rocket. Last year, there were 57 launches from Florida Space Coast from the Eastern Range. This year, again, targeting nearly 100. And this is the 13th of the year. You can see the slope of this graph here showing the ramping up of the launch rate here in Florida. We're going to show you part 2 of our interview now with Josh Bross, the Vice President of Revenue Operations. We talked to Josh earlier in the week before the first launch attempt, and he tells us a little bit about the Terran 1 rocket, the outlook for the Terran 1 rocket, the company's backlog of missions, both for the Terran 1 and the fully reusable larger Terran R that's now in development. So let's hear Josh speak a little bit more about the meaning and the significance of this launch.
I noticed this mission doesn't have a payload fairing that's going to be separating, no payload separation test as well. Can you just speak a little bit about the decision going into that? Why not test those elements of the vehicle on this mission?
Yeah, I think we were very intentional about trying to get to the pad as fast as we could to maximize the rate of learning. And if you look at history, history would suggest that first rockets by new companies don't make it all the way to orbit. And so you want to make sure we were biting off the technical scope that was most important for our learnings. And you look at how new rockets fail. There's a number of different failure modes that where systems can run into trouble, but those are really where we're focusing our efforts. So it's putting our effort into massive amounts of propulsion testing and the significant amounts of on-ground hardware in the loop kind of avionics testing, and full end-to-end structural testing to make sure that the system has the best chance of getting all the way to orbit that that we can get to, and gives us the best chance to collect massive amounts of data that we can then use to improve our systems going forward.
I noticed a tweet, I think earlier today, about the 3D printed structure that's inside the nose cone. Can you tell us a little bit about the significance of that?
Yeah, it's one of the first things that was printed by Relativity, and it's really a great kind of history piece to show, to contrast where we started and where we are. This part was printed several years ago. It's a relatively small metal ring. That was one of the first articles that we as a company managed to print. And the quality is not great, the scale isn't very large, and it's riding on top of a rocket that is the majority 3D printed. And so it really kind of bookends where we started and where Terran 1 shows where we are today. And I think it's a great memento to honor the past, and how we got to where we are today.
And before I let you go, can you walk us through some of the testing that you've done out at LC-16 over the last few months, and some of the milestones you've achieved to get to this point, and to give you confidence you're ready for flight without doing that final full duration static fire?
Yeah, so the test, we've gone through a massive amount of testing. So, I'll start with the engines, because those are the tests that have the prettiest pictures that people tend to be drawn to the most. But I'd say each systems testing is critical to the ultimate success. So the engines went through a qualification program, and then each flight engine went through an acceptance test where it was subjected to the full mission duty cycle that it would see in flight as an individual engine. Then the second stage engine was integrated to stage 2. That was put on a test stand at Cenis, and we fired the second stage for its entire mission duty cycle again. Then that stage was shipped on to the Cape to be integrated with stage 1. On the stage 1 path, again, each engine went through an ATP test for mission duration. Then all those engines were integrated into the first stage, and the first stage was hot fired multiple times at the Cape, totaling, Samantha would have to correct or verify the exact number of seconds, but it's something on the order of almost 3 minutes of hot fire testing, at full thrust as an integrated stage. So that's right on the same order, or right about the same amount of duration as the stage 1 will fire during flight. And then following that, we integrated stage 2 and went through multiple wet dresses. On launch day, there will actually be one final test, because the way launch works for us, which is similar to how it works for some other vehicles, is our engines light a few seconds before liftoff, and they come up to full power, and the system runs a number of automated checks to make sure each engine is within the acceptable bounds for flight. And only if all those come across as being go for launch does the launch hold down release and the rocket carries on. If anything's out of family, we will shut it down. So it's really kind of like a final integrated static fire test for launch. Um, and at this point in time, we see with all the individual propulsion tests that we've done and stage level tests that we've done that we've sufficiently mitigated all the major risks going into flight and are ready to go. Is that on the I guess kind of jumped ahead on the structures side, we did a parallel testing path as well, where in development we were doing tons of tests to characterize the as printed material, but then each stage, the inner stage and the nose cone as well, went through independent structural testing to verify that the integrated structures could survive the maximum predicted environments that they'll see in flight. We did that on test stands here in Long Beach, where stages were filled with liquid nitrogen to simulate the cryogenic temperatures. And then we used hydraulic actuators to push and pull on them to make sure that they were seeing more stressing environments than they'll see in flight. And then on the avionics side, we've run numerous on the ground hardware in the loop tests and hardware out of the loop tests to verify that the avionics and software play together in the ways that we're expecting in flight. Now, all these systems are put together, and we're trying to do the final end-to-end verification in flight itself. That's, again, as I was saying earlier, that's the only way you can actually do a full verification test of a rocket. You ultimately have to fly it, because there's things like the acceleration of the rocket through space that you can't actually simulate on the ground. You can simulate each one of these subsystems, but a rocket accelerating at 4 Gs or so is different than a rocket on the ground being held down on a test stand being tested.
Are you still planning on the $12 million price point for a dedicated Terran 1 flight?
To my knowledge, we have not changed the pricing for Terran 1.
And down the road, once the system is demonstrated, can you talk a little bit about your backlog, how many missions you have on contract and planned for Terran 1?
So we don't specifically call out the Terran 1 versus Terran R manifest at this point in time. And, more directly, we'll be looking to see what we demonstrate on this flight and talking to our customers to really refine our plans going forward. But we'll say our total backlog signed to date is it's over $1.65 billion, and that's spread across 12 customers and spread across Terran 1 and Terran R. So we have a significant backlog that we are very eager to deliver on across a number of customers.
That was Josh Brost, the Relativity Space Vice President of Revenue Operations, who chatted with me earlier in the week. We appreciate his time to talk to us about the Terran 1 rocket, the expectations for this test flight, this inaugural launch of this 3D printed methane-fueled rocket, as well as the outlook for this rocket and the company. That he mentioned they have more than $1 billion in a backlog of launches for the Terran 1 and the new generation Terran R rocket, which is a much larger, fully reusable launch vehicle that Relativity Space is currently designing. Here's a look at the comparison side by side of the design of the Terran 1, which is set to launch this afternoon, and the Terran R. The Terran R is more than 200 feet tall. It can also lift more than 20 metric tons of payload into Earth orbit. This puts it squarely in the class of comparable rocket to the Falcon 9 in terms of lift capability, SpaceX's Falcon 9 rocket, a similar lift capability as the Terran R. The Terran R, like the Terran 1, will be 3D printed and will be powered by upgraded Aeon R engines that are designed to be reusable, building on the methane-fueled architecture for the Terran 1. The Terran R looks a lot like SpaceX's Super Heavy and Starship booster, but it's about half the height of SpaceX's Super Heavy and Starship rocket, and about 20% or so of the lift capability of the Starship. But the Terran R, Relativity says, could be ready for its first launch potentially as soon as the end of 2024, and Relativity plans to build it out at their headquarters in Long Beach, California, and launch it from Launch Complex 16 here at Cape Canaveral, Florida, where I'm reporting live this afternoon, the same pad that the Terran 1 is awaiting liftoff from this afternoon. The countdown, again, is holding at T-minus 20 minutes due to concern about upper-level winds. We're awaiting an update from Relativity Space on those wind conditions. While we're waiting, we want to show you a video of some of Relativity's manufacturing methods. This video, a time-lapse from Relativity Space, shows the 3D printing architecture system, the manufacturing system they've developed at their headquarters in Long Beach, California. This is a Stargate 3D printer printing the structure for the first stage of the Terran 1 rocket. Here is stage 2 being produced. You see the propellant tanks inside stage 2, a methane tank for fuel, an oxidizer tank with liquid oxygen. Relativity produces these components using a proprietary aluminum alloy. This is a third-generation printer that can print objects as wide as 16 feet in diameter. Again, they call their 3D printing system Stargate. There is the nose cone for the rocket that's set for launch today. And then once the individual pieces of the rocket come off the 3D printer, they're assembled inside Relativity's factory. You see here the different segments of the first stage being put together to create that entire 80-foot length booster. And then once the booster arrived here at Cape Canaveral, it was integrated with the upper stage and the nose cone. See some of the technicians at work in the Stargate printer lab or module at Relativity's Long Beach, California headquarters. 85% of the Terran 1 by dry mass is 3D printed, including primary structures, propellant tanks, and most of the engine components, the thrust chambers, etc. Components not 3D printed include avionics, computers, valves, and fasteners, and things like that. Those are manufactured using conventional means. Back with a full screen shot of Launch Complex 16 now at Cape Canaveral Space Force Station. You can see the countdown clock continues holding at T-minus 20 minutes, awaiting an update on upper-level wind conditions. Relativity says, as you heard Josh Brost say in our interview with him, all their ground testing indicates that the 3D printed structures have the same factor of safety, the same reliability, structural strength as more conventional rocket components or rocket material like aluminum or stainless steel or carbon fiber. But one of the key tests today is to test that hypothesis and verify that those ground tests and models are accurate and that the Terran 1 with its 3D printed structure can withstand all of the vibrations and aerodynamic forces and accelerations of a rocket launch. Again, if you're just joining us and wondering why the launch has not occurred yet, the countdown is in a hold. The launch window today runs from 1 to 4 p.m. Eastern Time, 1800 to 2100 UTC. My name is Stephen Clark. I'm the editor of Spaceflight Now, providing live updates and commentary throughout the countdown and the launch if the rocket is able to get off the ground today. Again, the team is evaluating data on upper-level winds, which are marginal this afternoon. If you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us gain a larger audience for our coverage. So if you haven't hit the thumbs up or like button, that's something really easy we would really appreciate you do for us to gain a larger audience for our coverage. While we're waiting for the countdown to resume or for an update from Relativity Space on the wind conditions, one more look at the Terran 1 and Terran R rockets. Again, this is the first flight of the Terran 1, which is 110 feet or 33.5 meters tall. It's a stepping stone for Relativity Space, which is already in development of a much larger vehicle called the Terran R, which will be about twice the height of the Terran 1 with a lift capability of 20 metric tons to Earth or low Earth orbit. The Terran R will be fully reusable. Both the first stage and second stage are designed for recovery and reuse. Relativity has already secured launch agreements for the Terran R with a number of customers, including OneWeb, which has plans to launch their second-generation internet satellites on Terran R missions. They've launched their first-generation satellites on a mix of Russian Soyuz, SpaceX Falcon 9 rockets, and Indian GSLV rockets. Relativity says they have a backlog of about $1.6 billion of launch agreements, primarily with the Terran R. And there may be only a short future ahead for the Terran 1 because Tim Ellis, the 32-year-old CEO and co-founder of Relativity, has said that they see a lot of the revenue potential in the launch industry over the next few years in the medium to heavy class. And depending on how this mission goes, they may elect to shelve the Terran 1 at some point in the near future after one or a handful of flights and move on to the Terran R, the much larger vehicle. There is one Terran 1 launch currently on contract for a liftoff later this year with a rideshare mission for NASA with a number of NASA-sponsored CubeSats on board. The countdown clock has just recycled to T-minus 40 minutes and holding, so the clock is now at 40 minutes and holding. Recycling to this point from its previous hold at 20 minutes. We'll stand by for an update from Relativity as they work to coordinate a new launch time of 2:35 p.m. Eastern Time. That's the target launch time now. We'll see if the clock is able to resume in order to target that updated T0 or launch time. However, if the team is targeting 2:35 p.m., the clock should have, and the clock is now at 38 minutes and 20 seconds and holding. We'll stand by for that clock to begin ticking. Again, for a 2:35 p.m. Eastern, 1935 UTC launch opportunity. As we wait for the countdown clock to resume, here's another up-close look of the Terran 1 rocket vertical out at Launch Complex 16, fully fueled with methane and liquid oxygen propellants awaiting launch this afternoon, weather permitting. Upper-level winds primarily are the concern. The clock is now ticking, T-minus 38 minutes and 12 seconds and counting. Looks like they are timed. The clock is now timed for 2:35 p.m. Eastern Standard Time, or 1935 UTC for another launch opportunity. T-minus 27 minutes, 45 seconds and counting. Relativity continues to target 2:35 p.m. Eastern Standard Time. That is 1935 UTC for liftoff of their Terran 1 rocket from Cape Canaveral Space Force Station. SpaceX now at 25 minutes 15 seconds. Relativity Space, rather, at 25 minutes 10 seconds until liftoff of their Terran 1 rocket. Some more up-close views from Relativity's cameras out at the launch pad, showing the nose cone of the Terran 1 rocket and the upper stage, and the strong back, which will retract away from the rocket slightly in the final minutes of the countdown. There is no customer payload on this mission, as you may have heard Josh Brost from Relativity tell us earlier in our coverage. There is also no payload fairing that will be separating. That nose cone on top of the rocket will remain attached to the second stage throughout the climb into orbit. Inside that nose cone, Relativity has placed a token payload into that nose cone. That's a roughly 6-inch wide, 3-pound 3D printed ring. That was one of the first items that the company produced off of their 3D printers a few years ago. So as Josh Brost from Relativity Space told us, that ring is sort of a bookend for Relativity's history over the last 7 years or so since the company was established. They've come from printing that 3D printed 6-inch ring to printing 85% of the dry mass, the 20,000-pound dry mass of the entire Terran 1 rocket using additive manufacturing. We just saw a Coast Guard helicopter pass behind the Terran 1 launch vehicle. That's part of the standard sweep of airspace and maritime waters around the spaceport before every launch to make sure that the flight corridor is clear. Here's a look at the Terran 1 rocket and its various components. The bottom of the rocket on the left in this horizontal rendering is the thrust structure with 9 Aeon 1 engines burning liquid natural gas and liquid oxygen. The Aeon 1 engines will generate about 200,000 pounds of combined thrust at liftoff. The first stage contains methane and liquid oxygen tanks. Above that is the interstage, the adapter structure between stage 1 and stage 2. And inside that interstage on the is the Aeon vacuum engine, the Aeon 1 vac engine, which will generate about 25,000 pounds of thrust in the vacuum. That has an expansion nozzle for more efficient performance in the vacuum of space. And then the second stage also has methane and liquid oxygen tanks, much like the first stage. And then on the very top of the rocket, 110 feet above the ground level, is the nose cone with that mock 3D printed payload ring inside. That nose cone will remain attached to the rocket. The latest update from Clay Walker, the launch director for Relativity Space, indicates that upper level winds currently are go for launch. They're awaiting data from one more balloon to confirm that before the target launch time of 2:35 p.m. Eastern Time. The launch vehicle is healthy at this point. The rocket is fully loaded with methane and kerosene propellants. So again, this is one more look at the Relativity Terran 1 rocket, 7.5 feet diameter, 110 feet tall in this configuration. Now 18 minutes 55 seconds until launch. We're a couple of minutes away from the poll of the launch team by Launch Director Clay Walker here at Cape Canaveral Space Force Station. We just heard that checkouts of the reaction control system, that's the thruster system used for maneuvering of the second stage, is complete. Those checkouts of the RCS thrusters are complete. 18 minutes 34 seconds to go. Launch Complex 16 is located on the old Missile Row at Cape Canaveral Space Force Station, and we've labeled here some of the notable launch pads currently active here at Cape Canaveral Space Force Station. LC-16 kind of on the southern edge of this line of launch pads for Relativity Space. You can see here we've labeled the various pads in operation right now for NASA's Space Launch System up north at 39B, SpaceX at 39A, and then United Launch Alliance pad at Slick 41 and at Slick 37B. And then at pad 40 is where SpaceX launches Falcon 9 rockets. And then just to the south, about a mile south of Complex 16, where Relativity is counting down to launch, is the landing zone for SpaceX Falcon 9 rockets. Here's an aerial view of Launch Complex 16, where Relativity moved in 2019. They received a lease from the U.S. Air Force to modify this pad, which was previously used for Pershing and Titan missile launches from the 60s or late 50s up through 1988, and then it was set dormant, disused, for about 30 years until Relativity took over the pad, which is owned by the Air Force, leased by Relativity, to prepare it for launches of the Terran 1. Relativity put in a horizontal integration facility, or hangar, which you see here, for integration of the Terran 1 rocket, various stages of the rocket, and the payload fairing. They also installed propellant storage tanks at the pad, and the 4 lightning protection towers, which surround the pad, surround the Terran rocket to protect it from lightning strikes while it's vertical out at the pad. Lightning, of course, is pretty common here in Central Florida. You can see the methane storage tank as well as the liquid oxygen farm and the transfer lines where those propellants flow from the ground storage tanks into the rocket during the countdown. We're now inside of 16 minutes until liftoff. We're standing by for the launch readiness poll.
BC. BC go. BC go. GC1. GC go. GC go. GC2. GC2 go. GC2 go. Ground. Ground go. Ground go. AVI. AVI go. AVI go. FTS.
FTS go.
FTS go. RF.
RF go.
RF is go. GNC.
GNC go.
GNC go. Flight software.
Flight software go.
Flight software's go. Prop 1.
Prop 1 go.
Prop 1's go. Prop 2.
Prop 2 go.
Prop 2 go. Fluids 1.
Fluids 1 go.
Fluids 1's go. Fluids 2. Fluids 2 go. Loads.
Loads go.
Loads is go. Rock.
Ranges go.
Ranges go. OSM.
OSM is go.
OSM is go. RC.
RC go.
RC go. Vehicle.
Vehicle is go.
Vehicles go. CE.
CE's go.
C's go. LC.
LC is go.
LC is go. All parties have reported go for launch countdown.
Once the clock begins to roll, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or a manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify the LD and the RC on the primary net.
That was the voice of Clay Walker, Relativity's launch director here at Cape Canaveral. All stations reported a go to proceed with the terminal countdown. The automated countdown begins at T-minus 10 minutes, and the terminal countdown sequence will begin at T-minus 10 or T-minus 1 minute 10 seconds. 13.5 minutes now until the target launch time of 2:35 p.m. Here's a look at the trajectory for today's flight. This rocket, the Terran 1, will be heading due east from Launch Complex 16 out over the Atlantic Ocean, targeting an orbit inclined 28.5 degrees to the equator at an altitude of about 200 by 210 kilometers. That's 124 by 130 miles altitude. That's the target orbit, a very low orbit for this test flight of the Terran 1 rocket. T-minus 12 minutes and 10 seconds. We want to swing the camera briefly over to the south and look at landing zone 1, where a Falcon 9 booster is currently standing on landing zone 1 after landing yesterday, or on Thursday rather. The Falcon 9 booster, here you see it, booster 1062 in SpaceX's fleet. You see the crane out there. It'll be rotating that rocket horizontal in the next day or two and moving it back to a SpaceX hangar for refurbishment. This is the Falcon 9 that launched on Thursday with 40 OneWeb internet satellites. Swinging back toward Launch Complex 16 now. And then off in the distance, also north of Complex 16, is Pad 37. That's where United Launch Alliance has a Delta IV Heavy rocket awaiting launch in the next few weeks or the coming months with a classified payload for the National Reconnaissance Office. And then up north of Pad 37 is Pad 41. Well, there's Pad 40, which is empty right now. That's where the Falcon 9 launched on Thursday, SpaceX's launch pad. And then at Pad 41 is ULA's Vulcan Centaur rocket, standing vertical for a series of fueling tests that rolled out to the pad on Thursday for a tanking test yesterday. More tanking tests are on tap in the coming weeks ahead of that Vulcan rocket's first test flight by United Launch Alliance in May. And we're back on Pad 16 now. We just wanted to give you a little tour of the landscape here at Cape Canaveral Space Force Station. A busy range with rockets standing on the landing zone and at 3 different launch pads right now, awaiting upcoming flights. The automated countdown sequence will begin at T-minus 10 minutes for the Terran 1. That automated countdown sequence is now underway. That began at T-minus 10 minutes. The latest update from the upper level winds from the latest weather balloon indicates that the upper level winds are go for flight. That's the final weather balloon before launch. It'll take about 8 minutes from the time of liftoff until orbit insertion if everything goes according to plan on today's flight. The rocket will reach the point of max Q, or maximum aerodynamic pressure, at about 1 minute 20 seconds into the flight. The first stage will shut off its Aeon 1 engines 2 minutes 40 seconds into the flight, followed 5 seconds later by stage separation. That first stage booster will fall back into a predetermined impact zone and will not be recovered in the Atlantic Ocean. The second stage will light its single Aeon vacuum engine for a 5-minute burn to accelerate up to orbital velocity near 17,000 miles an hour. Orbit insertion expected around 8 minutes into the flight. The target orbit for today's mission ranges between 124 miles and 130 miles altitude. That's 200 by 210 kilometers at an inclination of 28.5 degrees to the equator. That is the target orbit for the maiden flight of Relativity's Terran 1 rocket. Final configuration of engine igniters now underway out at Launch Complex 16. Now inside of 5 minutes to launch. One more reminder, if you haven't done so, please hit the thumbs up or the like button here on our YouTube stream to help us attract as big of an audience as possible for our coverage of Relativity Space's Terran 1 rocket. Also, if you want to support our coverage, please consider donating in the Super Chat. Your contributions here are greatly appreciated because we're trying to bring you every launch from here at Cape Canaveral live here on our YouTube channel, and your support with the growing launch rate here in Florida goes a long way. 4 minutes, 15 seconds until launch. Now inside of 2 minutes until liftoff of Relativity's Terran 1 rocket. Seeing some views under the engine section of the Terran 1 where the 9 Aeon engines are awaiting ignition. 1 minute 45 seconds. The terminal countdown sequence will begin at 70 seconds before launch. That will begin a final check of all launch commit criteria. The countdown is holding at 70 seconds now. This is a hold point that is possible for the team to use if they need to. This is where the countdown held on Wednesday's launch attempt. This hold was apparently called due to a violation on the range. Relativity reports there is a boat in the restricted waters near the flight corridor in the range area. So the range is called a hold on the countdown. The range is currently red. The range is responsible for public safety around rocket launches here on the Space Coast of Florida. It's run by Space Launch Delta 45 of the U.S. Space Force. The range team is currently working to see if they can clear this boat, which has wandered into restricted waters under the flight corridor or around the launch pad here at Cape Canaveral. They want to make sure this vessel is out of danger and out of the flight path of the Terran 1 rocket. They want to clear this area in case there's a mishap or an accident that causes any debris to fall into the ocean. The countdown still holding at T-minus 71 seconds right now, just prior to the start of the final terminal countdown sequence, which begins at 1 minute 10 seconds prior to liftoff. While we're waiting, if you haven't done so, we remind you one more time to please hit the thumbs up or the like button if you haven't done that already. It helps us get as many people watching this exciting launch of the first ever 3D printed methane-fueled orbital class rocket. Also, a big thank you to those of you Relativity reports the boat apparently has been cleared out of the range area, according to Launch Director Clay Walker in the Launch Control Center here at Cape Canaveral. We're standing by for an updated target launch time, and when the clock will be able to resume to tick down the final 70 seconds until liftoff of the Terran 1 rocket. We want to thank those of you while we're waiting. Thank you for your support in the Super Chat. We've had several of you donate in the last few minutes. Your donations help us support our coverage, bringing you live video like this, independent coverage of launches here at Cape Canaveral. The countdown will pick up in 60 seconds, according to Launch Director Clay Walker. The new target launch time is 2:42 p.m. Eastern Time. The countdown clock has resumed. Inside of 1 minute, the flight computer is in countdown mode. The flight computer on the Terran 1 is controlling the final 60 seconds of the countdown. Engine start will come at T-minus 6 seconds. Final go has been issued for launch by Launch Director Clay Walker. 25 seconds. T-minus 20. T-minus 10, 9, 8, 7, 6, 5. We're going to stand by for engine start. Engine start. It looks like there's been an abort. There was an abort at engine start, after engine start. So the rocket has not lifted off. The rocket remains on the ground at Launch Complex 16. standing by for updates from Relativity Space on the next step here. A engine abort, such as the one we saw, is not entirely unexpected for the launch of a brand new rocket. Obviously, the Terran 1 remains vertical, safe, looks intact out at the pad. So right now there are steps underway to safe the vehicle and secure it after this last second abort. Again, aborts like this, not unexpected for the launch of a brand new rocket. We've seen these engine aborts many times. Just last month, the Japanese H-3 rocket aborted its launch after engine ignition before liftoff. Of course, some of the early SpaceX launches, including the very first Falcon 9 launch back in 2010, suffered an abort and engine startup before it successfully lifted off on its orbital test flight. See a big event underway from the Strongback out at Launch Complex 16. Relativity's team is currently assessing whether they're going to be able to recycle the countdown and try again today. They do have the ability to do a quick recycle if the problem is identified quickly and is deemed to be minor or something they can perhaps resolve with a software patch, for example. If it's a more significant problem that requires hands-on work, that would likely result in a scrub for the day. The launch window today extends until 4 p.m. Eastern Time or 2100 UTC. So just hang with us for a bit longer as we await word from Relativity Space on whether there might be another opportunity to go to launch before the end of today's launch window. Again, you're looking at a live view with the help of one of Relativity Space's cameras at Launch Complex 16 at Cape Canaveral Space Force Station, where the Terran 1 rocket is still on the pad after a last-second abort after engine start, but moments before liftoff. The launch team is assessing the cause for this abort. After engine start, there are a number of automated health checks that are performed on the engine performance as well as other parameters to make sure the rocket is fully healthy before it is released from its hold-down restraints for liftoff. And likely one of those launch commit criteria was not met, and the computer ordered a halt to the countdown. That would have been certainly an automated abort that close to launch. The clock has just recycled to T-minus 45 minutes and holding. So you saw that time change in the upper right of your view. So the team has not totally given up on trying again today. They're looking at the cause of this abort and seeing if it's something minor that can be resolved or masked, perhaps. Sometimes they can. If it's something minor, they can upload a software patch to modify some of the logic to not abort in the event of this happening again. A lot of times on these first launches, launch companies' engineers set limits very conservatively, and perhaps those could be loosened up. But if it's something more serious that needs analysis or inspection or hands-on work, that could be it for the day, but we're standing by, so don't go anywhere yet. The window is still open for another hour and 5 minutes. It's now 3 p.m. on the east coast of Florida, 3 p.m. Eastern Standard Time, or 8 p.m. UTC. 1 hour remains in today's launch window here at Cape Canaveral. Relativity Space is still holding out some hope for another terminal countdown. The clock would have to resume in the next 15 minutes or so from the current hold point at T-minus 45 minutes in order to launch before the end of today's window. It's now 3:05 p.m. Eastern Time. The window today for the Terran 1 launch closes at 4 p.m. Eastern Time. As you can see, the clock has been recycled to T-minus 45 minutes in holding while engineers assess the cause for that last second abort, which was called just 0.5 seconds before liftoff of the Terran 1 rocket, with the engines already running. They haven't given up on another launch countdown this afternoon before the close of the window, but if the clock remains at 45 minutes, it will have to resume in the next 10 minutes in order to meet the end of today's launch window. So the clock in real time is ticking, less than 10 minutes left until a decision point for today's launch opportunity. While we're waiting, if you haven't done so, please hit the thumbs up or the like button here on our YouTube stream. That helps us bring this coverage to as many people as possible. We're not sure we're going to see a launch today, but there's still a chance according to Relativity. Also, if you want to support our coverage, you can donate in the Super Chat here on YouTube. These donations are much appreciated, and this is a big help, a big source of resources for us to help bring you live coverage like this. We like bringing these live launches to as many people as possible in our audience. We've been covering launches here at Cape Canaveral since 1999. We've covered every launch from here at the Cape over the last 24 years. So we want to continue doing that in a new way now here on our YouTube channel. And to help us do that, to help us bring this to its full potential, your support is greatly appreciated. You can do that in the Super Chat with donations there. You can also join our YouTube channel. Depending on which membership level you select, you can gain access to members-only video features just for our loyal supporters. The countdown has resumed here at Cape Canaveral for a target launch time of the Terran 1 rocket at 3:55 p.m. Eastern Time, 2055 UTC. No report from Relativity on the issue that caused that last-second abort at 2:42 p.m. for today's first terminal countdown. But apparently it's either been resolved or there's some optimism that it will be resolved in time for 3:55 p.m. Eastern Time for a new launch opportunity just 5 minutes before the close of today's window. Coming up on 43 minutes until liftoff. Now the new launch time targeted for 3:55 p.m. Eastern Time, 2055 UTC. With the countdown inside of 42 minutes, this will be the last opportunity for the Terran 1 rocket to get off the ground today. Again, the 3:55 p.m. target launch time is just 5 minutes before the end of today's launch window. This recycle is not without precedent. It is rare, but not without precedent to go for another launch attempt the same day after an engine abort after engine start. The very first launch of a SpaceX Falcon 9 rocket back in 2010 did the very same thing. It aborted the countdown after engine start and before liftoff, and SpaceX was able to recycle the countdown and try again before the end of the window. And of course, the Falcon 9 lifted off successfully and made its way into low Earth orbit on its very first attempt. That was back on June the 4th of 2010. And the countdown has stopped here at 40 minutes, 44 seconds. We'll stand by for an update from Relativity Space. The count has resumed, now targeting a launch time of 4 p.m. Eastern Time, 2100 UTC at the end of today's launch window. So that reset of the countdown is now complete. So the launch time, just to recap, it was 3:55 p.m. Now it's targeted for the very end of today's window at 4 p.m. on the dot. 4 p.m. Eastern Standard Time, 2100 UTC. Rocket Lab's countdown is approaching T-minus 29 minutes and counting. We expect to hear from Launch Director Clay Walker in the next 10 to 15 minutes or so. He may come on the countdown net in the next couple of minutes, actually, and give a briefing. But the pre-launch readiness poll for this updated launch time of 4 p.m. Eastern Time is targeted for T-minus 16 minutes. That's about 12 minutes from now. That's when Clay Walker will poll various members of the Relativity launch team here at the Cape to make sure all stations are ready to proceed into the second countdown of the day. Again, the launch was aborted at 2:42 p.m. Eastern Time at just a half second before liftoff. That was a computer-commanded abort in the countdown. The 9 Aeon engines on the base of the first stage were already firing. Those engines shut off safely, and Relativity has reset their clock for a launch attempt at 4 p.m. Eastern Standard Time, 2100 UTC at the very end of today's launch window. So here's a look at the milestones to go, beginning at 16 minutes with the poll. The automated countdown sequence would begin at T-minus 10 minutes. Then there will be milestones in that last few minutes, including engine chill down, retraction of the strongback, and priming of the engine igniters on both stages of the Terran 1 rocket. The terminal countdown sequence would begin at T-minus 1 minute 10 seconds. And then, just as we've already seen earlier this afternoon, the engines would light at 6 seconds prior to liftoff. And then if everything looks good this time, computer on board the rocket will give the command to release hold-down restraints for liftoff at T0. Now 27 minutes from the final launch opportunity for Terran 1 today. T-minus 25 minutes and counting. Today's launch, the Terran 1 rocket is standing on Launch Complex 16 at Cape Canaveral Space Force Station in Florida. We've labeled that here along with some other launch pads at Cape Canaveral. The landscape here at the Florida Spaceport is filling up with a lot of active and soon-to-be active launch pads. In fact, just last week, the Space Force allocated 4 more launch pads to new up-and-coming launch providers here at the Cape. Those are not listed here, but those companies have been selected to take over some disused dormant launch facilities at the Cape for launches of their rockets over the next few years. Here are a listing of the active or soon-to-be active launch pads at the Cape. Launch Complex 16 is near the southern part of this list, of this row of launch pads, out on Cape Canaveral Space Force Station, just about a mile north of Landing Zone 1, where SpaceX recovers Falcon 9 and Falcon Heavy boosters after launch. Up on the northern end of this map is Kennedy Space Center with Launch Complex 39B for NASA's Space Launch System, 39A there, leased by SpaceX for Falcon 9, Falcon Heavy missions, as well as crew launches. And then below that, just to the south, is Pad 41 for United Launch Alliance's Atlas V and Vulcan rocket. Pad 40, one of the more active launch pads here at the Cape, is leased by SpaceX for Falcon 9 launches. And then Complex 37B is used by ULA for Delta IV missions. And then there's Complex 16 for Relativity, the landing zones 1 and 2 for SpaceX rocket recovery missions. And then Space Launch Complex 36 at near the eastern extent of Cape Canaveral Space Force Station is currently leased by Blue Origin. It will be used by their New Glenn rocket when it is ready to come online, likely in a couple of years' time. 22 minutes, 40 seconds now remaining until liftoff of the Terran 1 rocket. We showed this earlier in our coverage, but we want to show you one more time some aerial shots of what the Launch Complex 16 area looks like. Relativity won the rights to build this complex at Pad 16 from the Air Force back in 2019. The pad was previously used from the late 1950s until 1988 for missile launch tests of the Titan missile and the Pershing missile by the U.S. military. Its last launch was in 1988, and it sat dormant for about 30 years until Relativity took over the pad. Relativity installed or built a hangar, a horizontal integration facility, which you see here. That's where technicians mate the first and second stages of the Terran 1 rocket. They also erected 4 lightning towers. Those towers around the launch mount area are used for protecting the rocket from lightning strikes while it's vertical on the pad. You can also see propellant farms, methane tanks, as well as liquid oxygen ground storage tanks on each side of the pad in this aerial shot provided by Relativity Space. Pad 16 was also used in the 1960s for some ground testing, some hot fire testing of the Apollo service module engine by NASA. There's a view from Relativity inside their Launch Control Center here at Cape Canaveral Space Force Station. The team is led by Launch Director Clay Walker. And now a nice up-close shot of the 9 Aeon engines, which have already seen action today. They've already ignited for about 5 seconds or so during the previous terminal countdown. Then those engines were shut off safely. "20 minutes, 20 seconds until liftoff." These views from different cameras around Complex 16 come from Relativity Space. just joining us, you haven't missed the launch. The Terran 1 rocket is still on the pad, but Relativity Space is counting down to the final launch opportunity this afternoon at 4 p.m. Eastern Standard Time, 2100 UTC. That's the end of today's launch window. Relativity Space has already gotten down to a half second within a half second of liftoff earlier this afternoon. The countdown was automatically aborted due to an issue that Relativity hasn't told us yet what the technical issue was that caused that last second abort. But one of the parameters that the computers are monitoring in the final moments of the countdown apparently was tripped, and it was an automated abort. Computers ordered the halt to the countdown. Engineers have taken a look at the data and decided to press on for another launch attempt this afternoon. We're now about 2 minutes away from when we expect to hear the voice of Launch Director Clay Walker here at the Cape poll his launch team for their readiness to proceed into another countdown and launch attempt. If you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That really helps us a lot, helps us get as many people watching our coverage as possible as we await another opportunity, another attempt to launch the first ever orbital class 3D printed methane-fueled rocket. Next milestone in the countdown will be the launch readiness poll performed by Launch Director Clay Walker here at Cape Canaveral Space Force Station. We'll bring that audio to you when we begin hearing the poll. T-minus 15 minutes. We're standing by for that launch readiness poll. Now inside of 14 minutes until the launch time of 4 p.m. Eastern Standard Time, 2100 UTC.
Please provide concurrence for proceeding to launch operations with go, no, go. GC go. GNC. Flight software. Prop 1. Prop 2. Fluids 1. Fluids 2. Loads. Rock.
Ranges go.
OSM. RC.
RC go.
Vehicle. CE. LC. LC go. All parties report go for launch countdown.
All right, our team is being relentless here. We are not giving up, and we're going to give this one more shot with an instantaneous window at 1400 Eastern. As you heard, all parties have reported they are go.
The launch readiness poll is now complete, and all stations reported go for launch at 4 p.m. Eastern Time. Coming up on the start of the automated countdown sequence at T-minus 10 minutes. The countdown sequence is now underway. Here's a look at the trajectory for today's flight. The Relativity Terran 1 rocket will be heading on a course due east from Cape Canaveral Space Force Station. We've labeled the location of Launch Complex 16 here. We'll be targeting an orbit inclined 28.5 degrees to the equator at an altitude of about 200 by 210 kilometers, 120 by 124 miles. T-minus 9 minutes and 10 seconds. The Terran 1 rocket has what's known as a thrust vector control system. You can see that during testing inside the hangar last year. This is the steering system used to vector the thrust from the Terran 1's 9 Aeon engines in flight. 8 minutes, 45 seconds until liftoff. Before we get into the final minutes of the countdown, we want to ask you one more time, please consider donating in our super chat here that supports our ability to bring you this live coverage. We bring you all launches from Cape Canaveral live on our YouTube channel. We're also covering the wider launch and space industry on our website at www.spaceflightnow.com. Your support here in the super chat, donations here, as well as memberships if you join our YouTube channel. Support our coverage, and we please ask you to do that. Consider doing that if you like what we do. 7 minutes, 40 seconds until liftoff. Coming up on engine chill down in the next few moments, that's when the thermal conditioning begins on the Aeon engines on the first stage. 7 minutes, 25 seconds until liftoff. Great shot here of those Aeon engines. The chill down involves flowing a little bit of super cold liquid oxygen, the oxidizer, at cryogenic temperatures through the engine plumbing. You can see that activity, some of the oxygen gas there associated with that chill down now underway. This protects the engines and the engine plumbing from the risk of damage from thermal shock. Again, the rocket will be heading due east from Cape Canaveral after liftoff. Stage 2 igniters are now being primed for flight. Five and a half minutes until liftoff of the Terran 1 rocket from Cape Canaveral Space Force Station. Coming up on T-minus 5 minutes and counting. Here's a look at the launch timeline once more, just to refresh your memory. It's about an 8-minute ride to orbit from liftoff until the Terran 1 is in its low-altitude parking orbit. After liftoff, 12 seconds into the flight, the thrust vector control system that we showed you a few minutes ago will vector thrust from the Aeon engines to head east from the Cape. It'll reach max Q, or maximum aerodynamic pressure, at T plus 1 minute 20 seconds. That's a key moment in this test flight that will be a measure of whether the 3D-printed structures on this rocket can withstand the aerodynamic forces of launch. Main engine cutoff of the first stage is 2 minutes and 40 seconds into the flight. A few moments later, we'll see stage separation. The first stage will return to an impact in the Atlantic Ocean. It won't be recovered. The second stage will light its single engine for a 5-minute burn. A 5-minute burn to reach orbit. You'll notice here there is no payload fairing separation event. There is no payload or satellite separation event. There's no customer payload on this mission, and in fact the nose cone at the very top of the rocket will not be jettisoned. That helps simplify this mission because they want to make sure that the engines work, they want to make sure the 3D printed structures work for this critical test flight for the 3D printed Terran rocket. 3 minutes and 40 seconds until liftoff. The transporter erector or strongback has opened its clamps and is now retracting away from the rocket. 3 minutes, 25 seconds. T-minus 2 minutes and counting. T-minus 1 minute, 35 seconds. Everything looking good so far in this countdown. This is the second time Relativity Space has gotten this far today after getting within just a half second of liftoff a little more than an hour ago. The engines were already firing. They recycled the countdown, and now a minute 15 seconds from liftoff on a second try today. Coming up on the handover to the flight computer. And that handoff has occurred. The terminal countdown sequence is underway. T-minus 1 minute. The countdown is holding at 46 seconds. So that will mean the launch will not be happening today. The launch window has been consumed. We're at the end of the launch window. And with this hold, this will result in a scrub for the day.
Going to be scrubbed for the day. Taping up the vehicle. Thanks for playing.
So with that, it's been a dramatic day of countdown operations here at Cape Canaveral. We've seen Relativity Space get within a half second of launching their very first 3D printed Terran 1 rocket at 2:42 p.m., a little more than an hour ago. That countdown was aborted just a half second before liftoff. With the engines already firing, the engines safely shut off, and Relativity was able to reset the countdown and try again for the very end of today's launch window at 4 p.m. Eastern Time. But there was a hold inside of 1 minute, 46 seconds prior to liftoff. The countdown stopped. That's during a part of the countdown that's governed with computers. So it's an automated sequence. So a hold at that point is likely triggered by a computer alert. But we're waiting details from Relativity Space on the reason for the hold at 46 seconds. As well, we haven't heard any update from them on the reason for the abort earlier in the day either. Also, we're standing by for any news from Relativity Space on when the next launch opportunity may be for this Terran 1 test flight from here at Cape Canaveral Space Force Station. Before we sign off, we want to take a look ahead at some of the launches over the next few days. We haven't listed the Terran 1 Relativity test flight on this calendar because we're not sure when it's going to be launching. We'll pass that along on our launch schedule at www.spaceflightnow.com, as well as on our social media feeds when we get that news. But looking ahead the next few days, the other launches on our radar include the flight of a Rocket Lab Electron launch vehicle from up at Wallops Island, Virginia. That launch was supposed to go this evening at 6 p.m. Eastern Time, but Rocket Lab has delayed the flight, stood down from today's countdown due to strong upper-level winds, which were actually a concern earlier in the day here, but those winds here did trend in a favorable direction. Up in Virginia, that's not the case, so Rocket Lab will have to wait till another day to launch their Electron rocket, their small satellite launch vehicle, with 2 small radar observation satellites for Capella Space. Also, tomorrow, Russia is scheduled to launch a military satellite, an Olymp K2 military communications satellite on a Proton rocket from the Baikonur Cosmodrome in Kazakhstan. And the next 2 SpaceX missions on our calendar are coming up on Tuesday and Wednesday, March 14th and 15th, back-to-back days, with 2 Falcon 9s set to take off from different pads on different coasts, beginning with a launch here in Florida at Kennedy Space Center from Pad 39A with a Dragon cargo ship heading up to the International Space Station with scientific experiments and other supplies. And then on March the 15th, Wednesday, a Falcon 9 is set to fly from Vandenberg Space Force Base, California, with another batch of Starlink internet satellites for SpaceX's broadband internet network. We're also monitoring a testing of ULA's Vulcan rocket. This is the first United Launch Alliance flight-qualified Vulcan Centaur rocket out on Pad 41 here at Cape Canaveral Space Force Station this afternoon. A tanking test was completed yesterday on the first stage of this Vulcan rocket. Next up will be a tanking test on the Centaur upper stage. This will all culminate in a test firing of the Vulcan's 2 Blue Origin-built BE-4 engines in the coming weeks. That'll be a hold-down test firing, and then the launch preparations will begin in earnest for a test flight of the Vulcan rocket, ULA's own methane-fueled rocket, a much larger vehicle than Relativity's Terran 1, set to launch no earlier than May the 4th on its first mission, carrying a lunar lander, a moon lander for the company Astrobotic, as well as 2 commercial broadband satellites for Amazon. This mission will be the test flight of the Vulcan rocket, which is the replacement for ULA's Atlas V and Delta IV rocket families. And here's a quick look at Launch Complex 39A, where the next SpaceX mission is set to take off on Tuesday evening at 8:30 p.m. Eastern Daylight Time. It's 12:30 a.m. UTC Wednesday. Again, there's a time change for those of you in the United States tonight, heading to daylight saving time. So that launch will be from this pad at 8:30 p.m. Eastern Time on Tuesday, carrying the CRS-27 mission, a Dragon resupply spacecraft, to the International Space Station. The transporter Erector rolled into the hangar, SpaceX hangar at Pad 39A earlier in the week, and we expect it to emerge once it's integrated with the Falcon 9 rocket and Dragon capsule in the next couple of days and roll out to the launch pad for final testing as well as final cargo loading, and then liftoff on Tuesday evening. We'll bring that to you live on our YouTube channel. So we'll leave you with one more look of the Terran 1 rocket still on Earth tonight. Relativity Space has scrubbed today's launch attempt. This is the second launch attempt that they've scrubbed following a hold on Wednesday during the first countdown due to out-of-limits temperatures on liquid oxygen aboard the rocket. So while we await word from Relativity on a new launch date, we'll sign off and look for news on this launch attempt, the next launch attempt, on our website, www.spaceflightnow.com, as well as on our social media channels. And before we go, if you don't want to miss our next live stream, please subscribe to our YouTube channel. You'll get alerts when we're going live for this mission, this Terran 1 test flight for its next countdown, as well as the Falcon 9 on Tuesday and other launches down the road. So have a great weekend. I'm Stephen Clark reporting live from Kennedy Space Center. I want to thank Stephen Young for the camera work and providing this independent view of the Terran 1 on the pad. We'll see you next time.